Sixth grade, happy Thursday. We're ready for lesson 2 in science. We spent the last 2 lessons talking about the layers of the earth and the lithosphere that makes it up and how it's cracked into plates. And today we'll talk about how we believe those plates are moving. Today's lesson, guys, is going to be really heavy on evolution. They're going to toss out, as you can see here, 225 million years. We're going to take that in stride. We're going to talk about what scientists believe. We're going to compare that to what we believe as Christians. And you'll be prepared. I'm not going to skip this lesson because it talks about millions of years, guys. You have to know what other people believe so that you can stand strong in your faith and say, hey, this is what you think, here's what I think, but I need to know what you think so I'm not just in a meaningless argument by saying, you're wrong. Based on what? Well, I got to be able to defend why I believe in creation, just like they're going to give you evidence today on why they believe what they believe. So lesson 2 says this: how do Earth's plates help create these landforms? Those are the landforms we talked about on Tuesday, guys. Your mountains, your valleys, your trenches, your canyons, your plains, your plateaus. How does Earth make that up and do those things? One of the biggest guys of this is a guy named Alfred Wegener. He introduced the idea that the continents drift slowly over Earth's surface. Evidence from fossils, rock types, ancient climates, and seafloor spreading support this theory. So we're going to learn what a theory is. We're going to look at that evidence, guys. If you go back to Monday in the skill, they said we did all these things, we looked at all this evidence, and our logical conclusion is the Earth is really old. We're ready to rock and roll with some notes. Let's get going. Until the early 1600s, most people thought that Earth's continents were always in the same place. Then scientists began to notice that the coastline of some continents looked as though they could fit together like a jigsaw puzzle. So guys, if I look at South America, it looks like it should kind of fit right in here to Africa. Just like it looks like I can slide North America right in here, and it all looks like it kind of fits together. Okay, why did it take us to the 1600s? That's your extra credit, guys. 1600s is when we started to have maps of the whole world. So by the 1600s, our explorers had traveled around the world. Magellan was doing that, and the other explorers had hit these places, so we actually started to have a clue of what this world looks like. And until we had those maps, we had no idea that they all fit together. Okay? Number 1 in your notes says puzzle. Then in 1912, Alfred Wegener, a German scientist, suggested an explanation for the fit of the coastlines. Wegener thought that about 225 million years ago, the continents were joined in one large supercontinent that he called Pangaea. Pangaea is the word meaning all Earth. Wegener suggested that long ago Pangaea broke apart. So guys, if 250 million years ago we were just one big chunk of land, and then slowly we moved apart and we moved apart and we moved apart until we get to look like what we look like today, where you have South America and North America, you have Africa, Antarctica, Europe here, Asia here, and Australia down over here. Okay, so he said we used to be together. He named his supercontinent Pangaea. He said over millions of years we got there. Now I'm going to talk to you about why he thinks that. Okay, so fill in the blank, million. Wegener also introduced the idea of what we call continental drift, a theory that continents drifted apart in the past and they're continuing to do so today. So you've got the word continue. In other words, this is not, hey, we're here today and we're going to stop. They think it keeps going. A scientific theory is a well-tested concept, number 4, that explains a wide range of observations. So we have theories in all kinds of things, guys. Science is one of them. Math is another one. We talk about the Pythagorean theorem, his theory on how things work. Wegener's theory stated that as Pangaea broke apart, its pieces moved to different parts of the Earth to form today's continents. What's his evidence for this? In other words, how do you support it? The shape of the continents was evidence for Wegener's ideas, but it wasn't proof. In other words, God could have just created it to look that way. Other evidence supported Wegener's ideas. Plant and animal fossils found along the western coast of South America closely matched those found along the western coast of Africa. Wegener felt these similarities were impossible unless the species had once lived side by side when the continents were joined. So what he's saying is, we have found evidence of plants and animals here. We have found evidence of plants and animals here that are the same plants and animals here. Well, how do I get a plant that looks the same across an ocean? He says, well, it's a piece of cake. They used to at one time be this, touched together, and so the plants just grew by each other. Same thing with the animals. Okay, so fossils, same plants on the eastern coast of South America and the western coast of Africa. Next, he said, further evidence of Wagner's ideas was found in rocks. Layers of rocks along the eastern coast of South America match that of the western coast of Africa. So you got the same blanks here, guys, but now we're talking about rock layers. Wagner said that the layers of rocks must have been joined at one time. So if you've ever seen a picture of the Grand Canyon, guys, they're literally like different colors of rocks. If we match those rocks from the sides of the Grand Canyon, we say, hey, the Grand Canyon must have at one time been joined together, because look, the same colors are at the same heights on each side. He did that with different places from different continents. What forces could be strong enough to move whole continents? This was the question that Wagner couldn't answer. As a result, most scientists did not believe the idea of continental drift. They thought that the continents did not move even over millions of years. So down here, guys, he couldn't explain the force that could do that. And so I said, okay, you got some evidence, buddy, but what's doing it? I don't know. Okay, then I don't believe you. So Wagner wasn't really accepted with it. Over here it says is his fossil evidence, guys. So among the many bits of evidence for continental drift are two fossils. Fossils of an ancient plant called the Glossopteris are found in South America, Africa, India, Antarctica, and Australia. These identical plants could only develop in places that were connected at some time in the past. In addition, these fossils were also found in very cold regions of the Earth. So we actually found it down on Antarctica, guys. It doesn't grow there today. When the plants grew, these regions must have been located at warmer parts of the Earth. So they're saying Antarctica must have been up here, broke off, and got to the bottom of the Earth because we have the plant evidence. Fossils of an ancient reptile called a Mesosaurus have also been found in both South America and Africa. This is a freshwater animal that could not have obviously swam across an ocean that is full of salt water. Wagner claimed the reptile must have walked from one area to another when they were connected. So back over here, guys, you got the Mesosaurus reptile. So these are your fossil evidence. Okay, so I'm listening to this, I'm saying it sounds good. Christians, what explanation do we have? Guys, you have to decide if you believe in Pangea or not. Do I think God might have created the earth as one big supercontinent? Sure. Think about Genesis 1. He creates land, right? And he puts Adam and Eve on it, and he says, be fruitful and fill up the whole earth. Well, it'd be real easy for Adam and Eve to have kids and fill up the earth, is all they had to do was walk to it, right? Instead of it looking like this and saying, hey, I want you to fill the earth. Hey, Adam and Eve, have your kids figure out how to make a boat that can sail across oceans. That took us thousands of years to figure that out. Okay, as a Christian, how would we explain them getting blasted apart? I would explain it with the flood, guys. God could do amazing things with that flood. I don't think any of us appreciate the destruction that might have happened with the flood. So it could have looked like this and gone to this in a day after the flood. God could have simply created the world like this. So here's your chance for extra credit. At the top of your page, you write down the word Pangea. That's the supercontinent. And you write, I believe in it or I don't. Now guys, I can believe in Pangea without believing in the 225 million years. I can believe God created all the continents together, and then I can believe the flood blasted them apart. I could believe at the Tower of Babel, God said, I'm going to scatter the people. And maybe one of the ways he scattered the people is he moved the continents. I have no idea. God can do anything. He's all-powerful. So as a Christian, you can believe in Pangea, or you can say, nope, I don't believe in it. I believe God created the earth just the way it looks today. Choice is yours. Let's finish up the section. Cruising on in our notes for number 8. Not much other evidence supported Wagner's theory of continental drift. Later, but better methods to map the ocean floor were developed. Scientists then collected data that showed long, deep ocean trenches. They also discovered a chain of mounds along the floor of the Atlantic Ocean. These mounds are now called the Mid-Atlantic Ridge. Number 8 in your notes. Then, 50 years after Wagner, in 1960, scientist Harry Hess offered an explanation for the trenches and the ridges. He suggested that new crust forms at ocean ridges. He explained that magma, which is melted rock, molten rock, it's like lava, guys. Magma and lava are the same thing, except magma is inside the earth. It's called lava when it breaks the surface. pushes up through Earth's crust. As the magma cools, it forms new crust. More magma comes up and pushes newly formed crust and the old crust aside. This process is known as seafloor spreading. So you got number 9, both blanks. It makes new crust. That's called seafloor spreading. What causes the magma to rise? As Earth plates moves away from each other, the ocean floor spreads apart and magma rises to fill the gap. But what causes the plates to move apart? We go back in time. In the early 1930s, Arthur Holmes had developed ideas that scientists used in the 1960s to answer the question. When a liquid is heated, particles that make up the liquid move faster and spread apart. Hot liquids, therefore, weigh less. They're less dense as they get heated, and they float above the cooler liquids. As the hot liquid rises, it's going to then cool. It becomes heavier, and it again sinks. More hot liquid can then rise above it. This process is called convection. The mantle is not a flowing liquid, but its rocks are so hot that it flows very slowly. The result is that currents in the mantle constantly rise, circle around, and fall. When the mantle moves, the plates floating on it also move. Convection is the force that moves Earth's plates. So guys, you're in here in the 1930s, Holmes developed convection current. Hot substances rise, then cool and sink, heat up again and rise in a circular motion. This process is what moves Earth's plates. So they have a little picture of it here, guys. I get really hot. Obviously, the deeper into Earth I am, the hotter I am. So as I get really hot, I come to the surface. The farther away, I start to cool. So as I start to cool, I circle back down. I sink back into the Earth. I'm starting to get hot again. I'm so hot, I start to rise. I start to cool. And I'm going in this little circle, guys. Now, I don't want you to think that it's going whoop, super fast. It's very slow. And so over time, I'll start to move that. Guys, you're going to learn in the next lesson, that time is we're moving at about 2 centimeters a year. So that's less than 1 inch, guys. So am I going to be able to tell that America is moving in my lifetime? If I live 100 years, it would move about 100 inches. So if I live 100 years, it's going to move, 8 feet. Now you understand why they got the 2 million years, guys. So what they're doing is they're saying, hey, we know it's moving. We also know it's moving very slowly. So where did I come up with 225 million years? Well, if I take the Atlantic Ocean, which is now thousands of miles, and I start to do the math, it's going to take millions and millions of years to get there. That's their evidence. Their last piece of evidence. Although the explanation for seafloor spreading helped to support Wagner's ideas, scientists needed more proof of continental drift. In the early 1960s, scientists studying the magnetism of rocks near the mid-ocean ridge noticed a pattern. In some places, the magnetism faced south. In other places, it faced north, and in other places, it faced south. Scientists found alternating rows of north-south patterns spreading out in the mid-Atlantic Ocean ridge. What does the evidence mean? Earth's magnetism flips about every 500,000 years, is what scientists think. When rocks form from the cooling lava in volcanoes, the particular magnetic pattern of this time is frozen in the rock. Number 11. This was evidence that the alternating pattern of the rock had been slowly spreading out as new crust is forming. So guys, what they're saying is we got rocks forming here, and as we looked at these rock layers, we said sometimes the iron in it looks like it's pointing north because it was pulled there by Earth's magnetism, and sometimes it's pointing south, and they think that happens every 500,000 years. And so we know for a fact now that we're gaining new land. Okay, take that in stride, guys, with this evidence. Obviously, there's not a scientist alive, because no scientist lives for 500,000 years that can prove any of that stuff. So we have not had any written work, guys. This is just what they believe, and they make it sound like fact. You have to learn to read critically and say, sounds a little fishy. Have you ever heard an echo? You might be surprised to know that scientists use echoes to map ocean floor. Beginning in the early 1900s, scientists began to use sound waves to learn about the ocean floor. Sonar stands for sound navigation and ranging. It's the method of bouncing sound waves off objects and measuring the time it takes for the waves to return to where they started. Sonar is used mainly underwater, such as in the ocean. Today, scientists use different methods to send sound and detect their return in the ocean. On their return, the sound waves enter a computer where they produce electrical signals. The computer uses the information about time differences of the echoes to make an image of the ocean floor similar to the picture above, which shows the floor of Crater Lake in Oregon. So I run this sonar all over this, guys. I measure the times, and now we think we know what the Crater Lake looks like in Oregon. Crater Lake, the deepest lake in America. Maybe you want to write that down for extra credit. Deepest lake. Absolutely beautiful because it can't be polluted because it's at the top of a volcano. Good stuff. All right, guys, lesson 2. Have a great day.